Today's lesson is on section 10.7, applying the double angle and half angle formulas. There are two learning targets in this section. Learning target 10.7a is I can use the half angle and double angle formulas to evaluate trigonometric functions. And learning target 10.7b is I can use the half angle and double angle formulas to simplify and verify trigonometric expressions. So now let's take a look at what these double angle and half angle formulas are. So here they are on your screen. Again, these are ones just like the sum and difference equations or formulas. They are on that second trig sheet that I gave you. So you will be able to use that on the test. So the double angle formulas are listed here. Notice that for the cosine of 2u, or the cosine of 2 theta, 2x, whatever variable you choose to use, there are three things listed there. It's not that you have to do all three, it's you just pick the one that is easiest for you, or based on the information that you are given in the problem, maybe one of them is a better fit to the problem you're working with. So you only have to pick one of those three things. And then when you get down to the half angle formulas, notice that there is a plus or minus in front of the sine in the cosine formula. And again, it's not that it's going to be both a positive answer and a negative answer. You have to pick the positive or negative that fits for the original angle. So that plus or minus is determined by your original angle. So let me just write that for you. So positive or negative is determined by original angle. So you look at what quadrant, So look at the quadrant that original angle would fall in, and then do your all students take calc to determine whether your sine or cosine is going to be positive or negative. And then again with the tangent, there are two equations written there. You pick the one that best fits the problem that you're working with. You do not have to do both of them. You only pick one of them to work with. So now let's look at an example of this. So let's look at an example of learning target 10.7a. I can find the exact value of a tangent of 3 pi over 8, and then later we'll do b, the sine of 15 degrees. So let's start with that tangent of 3 pi over 8. Now to me, the easiest is to maybe convert these radians into degrees, because for me it's easier to think of, okay, what divided by 2 gives me, or what times 2 gives me the degree instead of in radians. So I'm going to go ahead and convert 3 pi over 8 into radians. So to do that, I multiply by 180 over pi. So then my pi's cancel. I end up taking 3 times 180, dividing that by 8, and I get 67.5, or in fractional form, I get 135 over 2. And the reason I go ahead and put it in the fractional form is that right there leads me right into knowing that I could do a half angle because it is 135 over 2. So that's what I'm going to do. I'm going to do the tangent of 135 over 2 degrees. It's not squared, it's degrees. So then I'm going to look at my tangent on my double angle, or half angle, sorry, formulas. And this is the one that there's two choices, so just choose one of them. And for this problem, it doesn't really matter because you're going to have to find the sine and the cosine of your u value, your top value anyways. So I'm just going to use the 1 minus the cosine of u all over the sine of u. Now keep in mind, when we did this, it was, and that was equal to the, no, not cosine, the tangent of u over 2. So that u value comes from the top number, meaning in this problem, the u value is going to be 135. So if I plug that in, I get 1 minus the cosine of 135 degrees over the sine of 135 degrees. Okay, so now I need to evaluate what the sine and cosine of 135 degrees is. Well, that's not on that nice sheet that I have, or that nice chart below the unit circle. So I need to do some thinking about this. So what we need to do is use reference angle. So if I think about where 135 is, 135 is over here in the second quadrant, meaning this angle here is 135. So I need to find the reference angle, or this angle right there. So to do that, I do 180 minus the angle, and I see that I get 45 degrees. So in other words, this means that these are the same thing as the cosine or the sine of 45. Now keep in mind, whatever quadrant it's in also determines the sign, as in positive or negative, of that answer. So all students take calc in the second quadrant, only the sign is positive, meaning that when I convert my cosine over, or cosine of 135 over to 45 degrees, I'm going to have to do the opposite of it. So negative cosine of 45 degrees all over then the sine of 45, because the sine is positive in the second quadrant. So I'm going to do 1 plus the cosine of 45 degrees all over the sine of 45 degrees. Okay, so now I can just look at my chart and I see that cosine of 45 is the square root of 2 over 2. Sine of 45 is also the square root of 2 over 2. Now I need to simplify this. So to do that, I'm going to get a common denominator on top first. So that gives me 2 plus the square root of 2 over 2. And then I'm dividing by the square root of 2 over 2, because that's what this big fraction bar here means. So now I can change, flip it. So I leave the first one, 2 plus the square root of 2 over 2, times it now by the reciprocal, so 2 over the square root of 2. Now I can go ahead and do some canceling, and I can cancel out this 2 with this 2, and then go ahead and multiply straight across, and I get 2 plus the square root of 2 all over the square root of 2. But in math, we don't like to leave radicals in the denominator, so I go ahead and multiply the top and the bottom by the square root of 2. Now keep in mind that top is a quantity, so I have to multiply everything on top, meaning I'm going to get 2 plus, 2 square roots of 2 plus 2 all over 2. Well, then 2 goes into everything, so then I've got the square root of 2 plus 1 over 1. So there is my answer to that first problem, the tangent of 3 pi over 8. So now let's look at part B, the sine of 15 degrees. So this one I think is a little bit easier, because I can think right off the top of my head that 15 is the same thing as 30 divided by 2. So then my u value is going to be 30. So then I go ahead and use my equation. Now remember, there's a plus or minus out front. We'll come back to that. Remember, that's determined by the quadrant. So we'll look at that in just a second. And then it is 1 minus the cosine of u. Remember, u being the top angle, so 30 degrees all over 2. Okay, so now let's look at that plus or minus. So if we're looking at the original angle, so 15 is in the first quadrant. So when I do all students take calc, everything is positive in the first. That means I'm going to use just the positive square root. So every time I write this now, I'm just going to have the positive, and since it's positive, I don't really need a sign out front. So then I'm going to go ahead and find the cosine of 30 degrees. So 1 minus the cosine of 30 degrees is the square root of 3 over 2, and then all that over 2. So now I'm going to find a common denominator on top. So that gives me, the 1 becomes 2 over 2, so I get 2 minus the square root of 3 all over 2 divided by 2. And then all that's inside the square root. Okay, so then I'm going to do leave, change, flip. So I've got 2 minus the square root of 3 all over 2 times 1/2. Again, still inside the square root. So then I end up with 2 minus the square root of 3 all over 4. inside the square root. And now I just break it up into the square root of the top over the square root of the bottom. So the square root of 2 minus the square root of 3 all over the square root of 4, which is 2. Now I don't have a square root in the denominator, so this is going to be my answer. Even though there is a square root inside of a square root, we really don't have a way that we can simplify that. So that is my answer. So now let's look at a second example of learning target 10.7a. So we're given that the tangent of a is equal to 3/4 when a is between pi and 3 pi over 2. They want us to find first the cosine of 2a and then second the cosine of a over 2. So what we're going to do is we're going to use that tangent of a to evaluate our different trig functions. So the first thing I'm going to start with is just going ahead and drawing my triangle. Since it says that a is between pi and 3 pi over 2, that means it's down here in the third quadrant. So I'm just going to use that to make my triangle. So I'm going to draw it. Remember, triangles always go back up to the x-axis. So there's my triangle, meaning that this angle right here, that is my a value. So that's a up there in that corner. So then it tells me that the tangent is 3/4. I know from my trig values, or from SOHCAHTOA, that tangent is opposite over adjacent. So that means that this side is 3, this side is 4. Now, keep in mind the quadrant it's in order for my angle to be down there in the third quadrant, then my point that is on that ray of the angle would mean that the point would have to be a negative x value and a negative y value. So that means both the 3 and the 4 have to be negative. That's why the importance of the quadrant is there, so you make sure you get any negatives that would possibly occur. Now I'm going to do my Pythagorean theorem to find the hypotenuse of this triangle. So negative 3 squared plus negative 4 squared has to equal this, we usually call it an r value, r squared. So 9 plus 16 equals r squared, or 25 equals r squared. So r is 5. So this here is 5. So now I've got all sides of my triangle. So when I go to evaluate the cosine of 2a and the cosine of a over 2, I can use, regardless of what trig function is there, I can find the value of it. So let's start with a. A is the cosine of 2a. So looking at those identities or those formulas, this was the one that had 3 different possibilities that you could choose from. Again, you can pick whatever one you want. It doesn't really matter in this problem. There isn't one that's better than the others. For this one, I would probably just pick one of them that only had one trig value, so you don't have to do both, but we can very easily get both the sine and the cosine from this triangle we just drew. But I'm going to go ahead and use the 2 cosine squared of a minus 1. So all I need to know is what the cosine of a is. So from my triangle, if I look at the triangle, cosine is adjacent over hypotenuse, so cosine is negative 4/5. So I have then 2, remember cosine squared means the cosine of a, that quantity squared. So the cosine of a is negative 4/5 squared minus 1. So then when I evaluate that, I just go ahead then and type that into my calculator, and when I do that, I get 7/25. And there is my answer. So the cosine of 2a comes out to 7/25. So now let's look at part B. So part B is the cosine of a over 2. So when I look at the formula sheet, I see that it's plus or minus, we'll deal with that in just a second, the square root of 1 minus the cosine of a all over 2. So now let's look at that plus or minus. If a is in the third quadrant, so it's somewhere between pi and 3 pi over 2. So if I know, so off to the side here, we'll just do it up on top. If I have pi a is less than that, less than 3 pi over 2. But I want to know where a over 2 is, because that's the angle that I'm looking at, meaning that I want to take and divide this by 2. Well, if I divide that by 2, then I need to divide everything by 2. So when I look back at that, then I've got that pi over 2, or not pi over 2, a over 2 has to be between pi over 2 and, if I simplify this over on the right side, 3 pi over 4. Then I look where those are at, and pi over 2 is my 90 degrees, or my positive part of the y-axis, and so it's this part here. And then 3 pi over 4 is somewhere over here in the second quadrant, meaning that a over 2 is going to be in the second quadrant somewhere, because it's going to be somewhere between those two lines that I just drew. So if I think of my all students take calc, sine is the only one that's positive in the second quadrant. Since I'm doing the cosine, that means that this quantity has to be negative. So I'm just going to keep that negative out front. So now I just do like I did the last time, plug this value in. So I get 1 minus the cosine of a was the negative 4/5 all over 2. So now I need to simplify that. Oops, and actually I wrote the equation wrong. It's actually a plus there from our sheet. So then that makes it 1 minus 4/5, which is actually, I'm just going to go right up here. So it's got the square root of 1 minus 4/5, or 1/5, and then divided that by 2, which is the same thing as saying 1/5 times the reciprocal, or 1/2. So it gives me then the square root of 1/10, or take the square root of the top, square the bottom, so 1 over the square root of 10. But we can't leave the square root of 10 on the bottom, so I multiply both top and bottom by the square root of 10, giving me the square root of 10 over 10. But then don't forget, I kind of lost it as I kept going, but this was negative, so all of these should have been negative, meaning my final answer is a negative square root of 10 over 10. So that takes care of Learning Target 10.7a, being able to evaluate using these double angle and half angle formulas. Let's now look at an example of Learning Target 10.7b, where they want us to either simplify or verify. So in this problem we have that we want to simplify 4 times the quantity sine of theta over 2 times cosine of theta over 2. So I'm going to go ahead and just multiply that out and simplify it. So then I get 4 times the sine of theta, cosine of theta, all over 4. Well, then my 4's, I can go ahead and cancel those, leaving me with just the sine of theta, cosine of theta. Now I just want to look at my formula sheet, and I know I do have one that says that the sine of 2 theta is equal to 2 times the sine of theta, cosine of theta. So it's very close to what I have. I'm missing that 2. So if I get rid of this 2 to bring it over here, I would divide both sides by the 2. So then these 2's are gone, leaving just the sine of theta, cosine of theta. So I have then either the sine of 2 theta over 2, or another way I could write it is 1/2 the sine of 2 theta. So either of these answers would be good for your final answer. Now keep in mind, if you write it the first way, the top way, the sine of, so this way right here, the sine of 2 theta over 2, you cannot simplify those 2's, because that 2 theta is within the sine function, so you can't do any canceling with numbers that are outside of that trig function. So that's why you have to leave it with that 2 in the denominator, or pull it out front and make it 1/2. Okay, so let's try another simplified problem. So again, this is Learning Target 10.7b. Simplify the cosine of 2 theta over the sine plus the cosine. So what I'm going to do here is looking at this, I really don't know that I have anything I can do. I'm not going to switch that cosine of 2 theta yet. I could possibly see that I have a sine plus a cosine on the bottom, so maybe I can do that. Looking at the trig sheet, I see that the sine over the cosine has, those three possibilities. I'm going to pick the one that has both the sine and the cosine in it, since my denominator has both a sine and a cosine. So looking at that sheet, I see that it is the cosine squared of theta minus the sine squared of theta. And then I still have that all over the sine of theta plus the cosine of theta. So now I have a couple different things I can do. I can either, if I look at this and I say, oh, there's really not anything I can think of, I can maybe multiply the top and bottom by the conjugate of the bottom, meaning that I would multiply top and bottom by sine of theta minus cosine of theta, and then that'll work out very nicely. Or I do notice that the top is a difference of squares, so I can go ahead and factor that. So I know then that that means because it's a difference of squares, I have the cosine of theta plus the sine of theta times the cosine of theta minus the sine of theta. Then I still have all that over the sine of theta plus the cosine of theta. So now if you notice, on both top and bottom, top I have cosine of theta plus the sine of theta. On the bottom I have sine of theta plus the cosine of theta. Now remember, you can add in any order, meaning that these two then are the same, so I can cancel those out. So the only thing then I'm left with is the cosine of theta minus the sine of theta. And then there's nothing else I can do. It's in sines and cosines, so that is my simplified form. So now let's look at one where we have to verify, because that learning target 10.7b was both simplify and verify using the double and half angle formulas. So this example says to verify that tangent of theta equals 1 minus the cosine of 2 theta over the sine of 2 theta. So I'm going to go ahead and start with the right side just because that's the more complicated side. There's a lot of places I could go with just a plain tangent. So I'm going to start with the left side, or sorry, the right side. I'm going to go ahead and do some substituting of my double angles. So I'm going to do 1 minus, now again there's that cosine of 2 theta, so there's 3 choices. Because there is a sine on the bottom, I'm going to go ahead and pick the one that has just the sine in it. So that says 1 minus 2 sine squared of theta. And then on the bottom, the sine of 2 theta is the same thing as 2 sine of theta cosine of theta. Now I'm going to go ahead and simplify that top by distributing my negative, so I get 1 minus 1 plus 2 sine squared of theta all over 2 sine of theta cosine of theta. So then on top, my 1's cancel, leaving me with 2 sine squared of theta all over 2 sine of theta cosine of theta. So then, since I do have 2's on both top and bottom, those 2's cancel. I also have a sine squared, which remember is the same thing as sine times sine. So one of those sines will cancel with the sine on the bottom, leaving me with a sine on top over a cosine, and then we know by our tangent identity that sine over cosine is tangent. And that's what we were looking for, so we are now done with this problem. Let's look at one more verify problem. So again, this is learning target 10.7b. I want to verify that the sine of 3x is equal to 3 sine of x minus 4 sine cubed of x. So with this one, I'm going to start on the left side with the sine of 3x. They're both sides are probably equally hard or complicated. I just, with the sine of 3x, I can kind of think of a couple places to go with it, so that's why I'm going to start with that side. But if looking at the right side, you say, oh, I have I can think of a place to start, then go ahead and start with that right side. But like I said, I'm going to start with the left side because I know that I could do something like the sine of 3x is the same thing as 2x plus x, and break it up that way, and then use my sum and difference formulas from section 10.6 to break this down. So we're using two sets of formulas for this one problem. So the sine of 2x plus x is the same thing as the sine of 2x times the cosine of x plus the sine of x times the cosine of 2x. Now I can go ahead and use my double angles, because in the first part I've got the sine of 2x, in my second term I've got the cosine of 2x. Well, the sine of 2x is the same thing as 2 sine of x cosine of x, and then I still have that cosine of x. Plus, then I've got the sine of x times the cosine of 2x. Well, in this case, I'm going to use, because I have a majority of sines here, since there's a sine in that half of it, I'm going to try using the 1 minus the 2 sine squared of x. Plus, I also know that I want to end up with just sines, so I don't want to introduce a cosine into it when I'm trying to get to sines. So now I'm going to simplify that first part. So I've got 2 sine of x, and then cosine times cosine is cosine squared of x, plus I'm going to go ahead and distribute that sign. So the sine of x minus 2 sine cubed of x. So I'm getting closer because I've got that cubed x now, or sine cubed of x. I still have a cosine there, but luckily it's a cosine squared, so I can go ahead then and convert that to a sine squared by using my Pythagorean identity. So cosine squared, the Pythagorean identity says that the sine squared of x plus the cosine squared of x equals 1. Equals 1. So then if I want cosine, I need to bring that sign over, so then the cosine squared of x is equal to 1 minus the sine squared of x. So I'm going to plug that in for my cosine squared. So 2 sine of x times 1 minus the sine squared of x plus the sine of x minus 2 sine cubed of x. So now I distribute my 2 sine of x, giving me 2 sine of x minus 2 sine cubed of x plus the sine of x minus 2 sine cubed of x. Now I just combine like terms. So I've got this 2 sine of x's plus 1 more sine of x, giving me 3 sine of x. And then I've got negative 2 sine squared of x. Nope, that's cubed. Negative 2 sine cubed of x minus 2 sine cubes of x. So that gives me then minus 4 sine cubed of x. And then that is what I was looking for, so now I am done. So that is how we use our double angle and half angle formulas to verify a problem. So now we've looked at being able to evaluate using the double angle and half angle formulas for Learning Target 10.7a, and being able to simplify and verify using those double and half angle formulas in Learning Target 10.7b.